In the first topic of this module, we are going to look at the good laboratory practice as well as the general laboratory safety. At the end of this topic, you should be able to describe the requirements and also the importance of good laboratory practice. You should be able to state the 5S system for good housekeeping in the workplace and its importance. You should be able to describe the general principles of laboratory safety and to name some of the safety equipments used in the laboratory, including the fume hoods and biological safety cabinets. You should be able to identify the common laboratory safety signs and symbols. And lastly, you should also be able to describe the importance of safety practices across the different industries. The lecture recording for this topic will be divided into a few videos. Firstly, we will spend some time to look at the good laboratory practice, followed by the 5S system for good housekeeping in the workplace. And lastly, we will also look at the safety practices in the laboratory and also across different industries. In this section, we will be looking at the principles of good laboratory practice as well as its importance. As a science student, regardless of which diploma you are in, most likely you will be required to work in a laboratory. So why is it important for us to have good laboratory practice, and how did it come about in the first place? In the early 1970s, the US Food and Drug Administration was alerted to a number of cases of poor practice in the toxicological laboratories in the USA. Hence, they conducted an in-depth investigation in about 40 laboratories. The result revealed that there were many cases of poor practices in the laboratories, and in some cases, there were even deliberate fraud being detected. For example, the data reported were inaccurate or missing, and there were even studies being reported but were never carried out. The result of this investigation caused some companies being closed down and some of the management staff being imprisoned. And also the FDA concluded that there was a need to establish a quality management system for the laboratories. The original principles of GLP were developed by FDA following the investigation in the 1970s. So GLP have actually been around for quite a few decades. Today, most of the laboratories follow the GLP principles by OECD, Organization Economic Cooperation Development. So based on OECD's definition, GLP is a managerial quality control system covering the organizational process and the conditions under which non-clinical health and environmental safety studies are planned, performed, monitored, recorded, reported, and archived. I have bolded a few keywords in this definition. Firstly, GLP is a quality control system, so it controls the quality of the studies performed by the various laboratories. And it covers non-clinical studies, meaning that it doesn't cover clinical studies involving the use of human subjects. And it is about safety studies. So for example, studies investigating the safety aspects of a chemical or a pharmaceutical products. It doesn't cover other aspects, for example, the functional properties, for instance, whether a drug is effective in treating a disease, or maybe, for example, whether a food is tasty or not. And lastly, it covers the various stages of a study, right from the planning to the reporting and archiving stage. I will talk about it more in the subsequent slides. Having a standard quality control system for the laboratories is very important as it can promote the quality and validity of the test data. So for instance, if another laboratory wants to replicate your study, if they follow your laboratory's test method and protocol, they should be able to produce the same test result and outcome. Okay, hence, it can promote the mutual recognition of the study data across the different laboratories in the different countries. and eventually it's able to reduce the duplicative testing and hence shorten the time to market for the new products. So the new products can actually undergo a faster testing because it doesn't have to be repeated tested in different laboratories and different countries, and it can go to market faster. Singapore has been adopting the GLP since 2007. So later on, some of you, when you go to laboratories for your internship to work, you might see that your laboratory has been GLP accredited. So that means the laboratory has been following the OECD GLP principles. GLP covers the non-clinical safety testing of test items across a wide range of industries, including pharmaceutical, biomedical, food, veterinary, and also chemical industries, right? So hence it's very relevant to all of you because it covers all your diploma courses. We have talked about GLP covers safety studies, but what kind of a study actually falls under safety studies? Here are the list. For example, it covers toxicity studies. That is referring to whether the drug or chemical has any short-term or long-term toxicity effect. Mutagenicity studies, whether it will cause any gene mutation. And it also covers whether the chemical has any toxicity effect on the environment. If it is a pesticide, whether it will cause any residue in food or animal feeds. So to summarize, GLP doesn't apply to the analysis of samples from human clinical trials. So it doesn't cover studies using human subjects because that is governed by another set of a principle called good clinical practice. Hence, it is not under the scope of GLP. Okay, I just want to use this slide to show you where does GLP come into place in, for example, drug development. So this diagram shows a classical drug development pathway. For example, different research teams want to develop a particular drug to treat a specific disease. So during the initial discovery and research stage, there might be thousands of candidate products, but probably only less than 1/4 of them are able to enter into the preclinical stage where the safety of the drug is being tested using laboratory animals. So this stage is governed by GLP. And afterwards, probably only less than 5 of them can pass through the preclinical studies and enter into the clinical trials. So this is the stage governed by GCP, the good clinical practice, and also the GMP, which is the good manufacturing practice. And eventually, probably only one drug is approved, okay, and can enter into the market. So after entering into the market, there is also another set of principle called the GPVP to monitor the safety of the product already sold in the market. Okay, so actually for those of you who is studying pharmaceutical diploma, you will notice that it is really not that easy to develop a drug and to be able to market it to the consumers. Okay, so now we have covered what GLP is about, its scope, and also its importance. Now we shall take a closer look at the various GLP principles, also known as the different section headings. As mentioned earlier on, GLP covers from the planning of a study or the end to the archiving of the study results. So it is divided into the following section headings, namely organization and personnel, quality assurance, facilities, apparatus, materials and reagents, test systems, test and reference items, standard operating procedures, also known as SOPs, performance of the study, reporting of study results, storage and retention of records and materials. So in the subsequent slides, I will go slightly more into detail into the various aspects. Firstly, organization and personnel. For every study conducted, we should always make sure that the roles are clearly divided and specified so that if there is anything going wrong, we always know who should be responsible for that. So under GLP, we divide the person involved into management and also staff. Staff are the person who will be carrying out the study, who will be doing the experiment. On the management side, they should ensure that the necessary facilities, materials, equipment, procedures, and resources are in place for the duration of each study. So in other words, they should have a helicopter overview of the entire study. They should make sure that the resources are sufficient so that the study will not be suspended in the middle of it because of insufficient resources. And for staff, they should be trained in the relevant procedures and should be responsible for the quality of the data because they are the one who will be doing the experiment and producing the data. Secondly, quality assurance. In general, quality assurance refers to any personnel who is responsible for ensuring the products and services meet the standards set by the company. Under GLP, QA will perform inspections to ensure that GLP is being complied with, and they report to the management. They should be independent from the conduct of the studies. So for example, if you are the person who does the experiment, then you shouldn't be appointed as QA personnel. This is to ensure the independency of the inspection and also to avoid any conflict of interest. We should also ensure that the facilities are appropriate and also conducive to carry out the study. If there are more than one activity going on at the same facility, then there should be an adequate degree of separation. Each activity should have its own designated space. And facilities are also used to hold the archives of the test results. So we have to ensure that the archives are properly kept, they are not lost or damaged. Next, all apparatus, for example, instruments and equipment, including any computer software, should be fit for purpose and should be periodically inspected, cleaned, maintained, and calibrated. This also applies to systems controlling environmental factors. For example, if you are using any fridge or freezer, and for animals, typically they need to live under certain conditions, for example, certain temperature or humidity level, then that should be properly maintained as well. Chemicals, reagents, and solutions should also be clearly labeled and fit for the purpose. Test systems. A test system refers to either the biological, chemical, or physical system used to conduct a study. So basically, test system is what is being tested upon. For example, if we want to evaluate the safety of a certain drug and we use some equipment to collect the data, then the equipment could be seen as either a chemical or physical system. And sometimes we want to test the drug on a laboratory animal. Then in this case, our test system would be a biological test system. Regardless of which test system we use, we should always ensure that the system is properly maintained so that we can collect quality data. Previously, we mentioned that in the 1970s, FDA conducted an investigation into some toxicological laboratories. So one of the poor practice they found out was that sometimes the animals were not well maintained and they died halfway. And what the study personnel did was simply to replace the dead animal with a new animal to continue the study. This is definitely not appropriate and will not be able to generate accurate results. Test and reference items. Test item refers to what is being tested. For instance, in our previous example, we want to evaluate the safety of a certain drug, then the drug is a test item. For test item, we should know everything about it, right? For example, its identity, batch, purity, composition, concentration, expiry date, etc. Reference items, also known as controls, are also typically included as part of the study for comparison or for validation of the test result. Standard operating procedures. So subsequently, if you start to work in the lab, you will find this term SOP very common and familiar. SOPs are documented procedures which describe how to perform tests or activities. And it is typically very comprehensive. It describes how to perform a task in a step-by-step manner. So anybody new to the experiment will be able to follow it. Hence, it will help to ensure the quality and integrity of the data because all the operators will be following the same kind of a protocol. And this is also typically part of the new staff training procedure. Performance of the study. Every study should have a comprehensive study plan. It must be authorized by the management and made available to the staff before the study can begin, not during it. Each study plan should specify what the test is about, the objective, what is being tested, the test item, what the test item is being tested on, the test system, as well as in details what will be done during the entire course of the study and when it will be done. And during the study, raw data will be generated. Raw data are the original record of observations and measurements. They are very important because later on, if there is any query or doubt about the study result, we will always refer back to the raw data to check. Hence, it must be recorded promptly and accurately. Reporting of the study results. For every GLP study, or if the study is pretty big, it might be divided into different phases. For example, stage 1, stage 2, stage 3. There must be a final report containing a description of the methods used and also the results obtained. The report should be audited by the QA personnel and formally signed by the QA personnel and also the management. And each report should also carry a declaration of compliance with GLP so that we know that the study is conducted under the GLP framework. And even the aborted studies should be described in the summary report. This is to prevent any deliberate hiding of the results. Storage and retention of records and materials. At the end of the study, the raw data shouldn't be simply discarded. Instead, they should be properly maintained and archived for future references, and typically they should be kept for quite a number of years. In this video segment, we are going to learn about the 5S system for good housekeeping at workplace. First of all, what is the 5S system? The 5S system is the housekeeping method in order to achieve a clean and orderly workplace. It was initially developed by the Japanese, and later on it became so famous that it is adopted by the companies worldwide. By adopting the 5S housekeeping system, we are able to improve the quality and productivity at workplace, and also to reduce the chances of accidents and improve workplace safety. The 5S system is also being adopted across different industries. For example, here I have listed examples of job scope from the food, biomedical, and also the chemical industry. As you can see, whether you are being a food technologist or biotechnologist or a QC technician working in the chemical industry, the common thing is that you are required to be able to perform the 5S housekeeping. Hence, I think this 5S system is actually very relevant for all of you, regardless of which diploma you are coming from. Under the 5S system, we have 5 different levels. The terms all start with the letter S. They are Siri, Seton, Seiso, Sekesu, and Shizuke. So these are the pronunciation of the Japanese word. And in the brackets, it is the English word which carries the same meaning as the Japanese word. And here we have definition for each level. I will go into more details in the subsequent slides. The basic level of a 5S system is called SIRI. It involves the sorting and throwing away the unnecessary items. Basically, we need to look at the workplace and to decide what is necessary and what isn't. And for those items we don't really need, we should remove them from the workplace so that the workplace is less cluttered. And we also should remove our personal items which is not really required for work. And we could store the items needed by most people in a common storage area so they are more easily accessible. Here are just two pictures showing the example of poor SIRI and good SIRI. On the left-hand side, we can see the workplace is cluttered with a lot of things, among which I think most are not really required for work. This will make it harder for us to retrieve the items we want and reduce the work productivity. And poor SIRI could also cause safety hazard. For example, sometimes we bring along our personal belonging to the chemistry lab. In this case, the bottle containing the sodium hydroxide actually looks identical to the water bottle next to it. If we accidentally take the wrong bottle for drinking, serious accident could happen. The second level of a 5S system is called SATAN, also known as set in order or straighten. So basically, after putting away the unnecessary items, we should also organize what is remaining. We can do so by storing similar items together, in which we can use human factors consideration. For example, we can store items which are more frequently used at more easily accessible location so that we can quickly find them. Each item should have its own designated place and it should always be put back to that place after each usage. And we can further save the space by storing items at places like shelves and the storage cabinet. The third level is called SASO. It involves the cleaning and inspection of the workplace. Basically, after the organization of the workplace, we should also ensure that it is always kept at its best cleanliness level. The purpose is not only to make the workplace look nice, but also to make any problems or the equipment malfunction more obvious during visual inspection. For example, if the floor is very clean, then any leaks from the equipment will be very obvious, and then we can do the maintenance or repair of the equipment. The fourth step, Sekizu, is basically to standardize the achievements from the earlier three steps. It involves documenting the procedures and guidelines for the earlier S. And short briefings could be done regularly to remind staff about following the 5S system. Once the previous 4S have been achieved, they need to be properly maintained in order to become the new ways to operate. At the last level, Shizuki, also known as sustain, the aim is to make 5S system part of the company culture in order to avoid a decline back to the old ways of doing things. A 5S audit should be conducted regularly in order to maintain the kind of standards. And at this level, typically employees are very motivated to keep a clean and tidy workplace. For example, they might remind each other about good housekeeping. So here is just one example of the 5S audit checklist the company can use to check whether the 5S standards are being followed. Implementing the 5S system will bring about numerous benefits. For the employees, adherence to the 5S system will create a cleaner, more organized, and therefore cozier place to work. The employees will be better disciplined. It will be easier to locate objects because now they are more organized. And there will also be less chances of accidents occurring. For example, trips and fallovers due to cluttered workspace. For the employers, the companies, 5S system will bring about better workers' productivity and more efficient use of the time. This is because now workers don't need to spend a lot of time trying to locate the things they need, and also because only the necessary things are bought and kept at the workplace, there will be reduction of the cost and also less wastage of the material. Eventually, it will bring about better workers' morale as well. In this section, we'll be looking at some of the general lab safety guidelines you should be following when you are working in a laboratory. Depending on the type of lab you are working in, the specific rules may be different. For example, the use of personal protective equipment, selection of the laboratory safety equipment, laboratory design, disposal of the hazardous waste, and also the regulations and guidelines. But in this segment, we will just be talking about some of the common practices you should be observing when you are working in a lab. Safety habits should be a part of your daily life. While in the laboratories, all users must take special care and responsibility to ensure their safety. Firstly, attire. You should always wear the correct laboratory coat at all times in the laboratory. For example, you shouldn't be wearing a chemical laboratory coat when you are working in a food lab. Your lab coat should be buttoned up at all times. When you are going for restrooms, you should remove your lab coat. This is to avoid any potential cross-contamination. Always wear closed and flat shoes and long pants when working in the laboratory. Wearing covered shoes and long pants can protect you from any potential chemical spillage, and flat shoes will reduce the chance of trips and fall over. Sandals and tights are not allowed. The reason why tights are not allowed is because tights are in close contact with your skin. In case there is any chemical spillage onto the tight, actually the chemicals can easily seep into your skin and cause even more severe injury. Restrain long hair and loose clothing. Long fringe should be pinned up. This is because they may get caught in fire or tangled with the instruments and cause danger. You should also wear additional personal protection equipment as instructed. For example, goggles, gloves, or thermal gloves when handling hot objects. The picture on the right-hand side shows an example of the proper attire. You will also be seeing this picture pasted onto the doors of the various laboratories as a reminder. Upon entering the lab, bring only your lab manual, pencil case and wallet into the lab. Put your bags and files in the student's pigeonholes provided as shown on the picture here. This is to avoid overcrowding of the working bench and damage in case of spillage or fire. Always work or enter the lab only when the instructor is inside the laboratory. Upon your first time working in the lab, please also look around to locate the various safety features and equipments in the laboratory. For example, first aid cabinets in case of any minor injury, eye wash and emergency shower in case of any chemical spillage into the eyes or onto the skin, fire extinguishers and emergency exits in case of fire, broken glass containers for the glass shards, and cleanup materials for spills. While working in the lab, do not eat, drink, smoke, store food, or apply cosmetics. Before operating any equipment, you should get proper training from the lab instructor first. And make sure the equipment is in good working order. Keep all liquid away from the edge of the lab bench to avoid any spills. Never leave Bunsen burners on or other heating source unattended. Keep flammable materials away from the open flame, for example, the Bunsen burner. Keep water away from the electrical cord of the instrument. For example, do not put the instrument near the water sink. Report to the teacher in charge if a lab accident has occurred, however minor, be it a spill, burns, or fire. If you get in contact with chemicals in your eyes, wash your eyes immediately using the eye wash and inform the teacher in charge. Report all breakages of the glassware or equipment damage to the teacher in charge. Hand protection should be applied when picking up the broken glass. Broken glassware should be disposed in a special container called broken glass, as shown in the picture here. Before leaving the lab, you should properly dispose of any waste into the designated place. For example, the biohazard materials should be disposed into the biohazard waste bin, as shown in the picture here. Chemical waste should be disposed into the designated chemical waste bottles instead of being poured into the sink. You should also apply good housekeeping. For example, your own bench top should be cleaned and dried thoroughly. The apparatus should be cleaned and returned to the proper storage areas. You should also maintain the cleanliness of the common working areas. For example, the weighing stations should be properly cleaned. Okay, in this section of the video, we are going to look at some of the common laboratory safety equipments, namely the laboratory fume hoods and the biological safety cabinets. The chemical fume hoods and biosafety cabinets may look a bit similar in appearance. Both of them will protect the laboratory workers, which is you, from the laboratory hazards during experiments. However, the purpose, function, and operation differ quite significantly. I will explain about these two equipment in the subsequent slides. A chemical fume hood is designed to keep toxic or irritating fumes away from the general lab area. As you can see on the left-hand side, the picture on the top is the one I have taken from one of the chemistry lab in the school. The fume hood contains a black bench area where we can place the apparatus, equipment, and the chemicals. There is also a shield in between the user and also the chemicals inside. Below, the lab user is demonstrating the correct usage of the fume hood. Firstly, the shield must be lowered down to a certain level in order to serve the protection purpose. Secondly, only your hands should be inside the fume hood to do the operation, not the other parts of your body. Because sometimes students want to see the chemicals clearly, so they squat down and then their head is actually partially inside the fume hood. Again, that means you are being exposed, right, to whatever toxic or irritating fumes, so that is not the correct practice. The fume hood is usually used to handle the hazardous chemicals, for example, toxic, reactive, flammable chemicals, or other volatile materials. For example, if you are handling the strong acid and alkaline, then you should be doing that in the fume hood, not in the open lab area. A fume hood is designed to protect the user by continuously delivering the airflow away from the user. As we can see on the diagram on the right-hand side, air flows from the environment, and then it carries away whatever fume generated by the hazardous material and then exit to the environment. The user is being protected because the fume generated is not directed back to the user. But we say that the fume hood doesn't offer protection to the product or the environment. This is because when the air flows from the environment, it is not being filtered. Hence, maybe the air is dirty, but it will just come into contact with your product in the fume hood. And it doesn't offer protection to the environment as well, because whatever fume exiting the fume hood is not being filtered as well, so it will just enter into the surrounding environment. Next, biosafety cabinets. This is a picture taken at one of the microbial lab in our school. As we can see, it looks a bit similar to the chemical fume hood. It also offers an enclosed workspace with a shield between the internal environment and the user. However, the function is quite different from a fume hood. We have learned just now, right? A chemical fume hood is used to handle the hazardous chemicals. BSCs are used to handle hazardous biological agents, for example, infectious microorganisms. Hence, it is typically being used in life science research, cell culture processing, etc. BSCs are equipped with high-efficiency particulate air, also known as HEPA filters, which can effectively trap all known infectious agents. Let's take a look at the right-hand side diagram to see how it works. The surrounding air enters into the BSC chamber and is being circulated inside before it passes through the HEPA filter and released into the environment. BSC provides user protection because the contaminated air inside is not being directed back to the user. It also offers protection to the environment because the air being released is actually being filtered, so whatever infectious agents are being retained. And BSCs can also be designed to protect the product as well. Some of the BSCs can equip with another filter to filter off the entrance air so that the product is in contact with microbial-free air from the outside. Depending on the safety level, BSCs can be further classified into Class 1, Class 2, and Class 3. The one most commonly seen in our school is the Class 2 BSC. You will learn about it in more details in subsequent topics when we talk about the biological hazards. Next, we shall look at some of the common safety signs and symbols in the lab. Firstly, emergency exit signs. It shows the direction of the emergency exit. So in case of emergency, for example, fire, you should evacuate towards the emergency exit direction. The first aid sign shows the location of the first aid kit. In our school, the first aid kit is typically located at the corridor of the laboratory area. Fire extinguishing sign. It shows the location of the fire extinguisher in case of fire. And typically, the fire extinguisher is placed near the door of each laboratory. Emergency eye shower sign shows the location of the emergency eye shower. Emergency eye shower is typically at the sink area. Use immediately if your eye is exposed to a hazardous chemical. Emergency shower sign shows the location of the emergency shower. Use immediately if large area of your skin is exposed to a hazardous chemical. These two signs show that smoking and open flame from match or lighter is not allowed in the lab because there could be flammable substances in the laboratory. Certain work environment requires additional personal protection equipment. The head protection sign is typically seen in the construction industry to prevent people from being hit by the falling object. So personnel is required to put on helmet when entering such workplace. Eye protection sign. The personnel is required to put on safety glasses when entering the workplace. In our lab, we actually don't really see this eye protection sign, but by default, if you're working with chemicals, you should be wearing with the goggles all the time. Ear protection sign. Personnel required to put on ear muffs or earplugs when entering the workplace. This is because at certain workplace, the equipment will generate a lot of noise, which can cause hearing impairment. Respiratory protection sign. If there's going to be hazardous fumes generated at the workplace, then the personnel should put on respiratory when entering such workplace. Hand protection sign, personnel required to put on gloves. Footwear protection sign, personnel required to put on covered footwear. Again, these two signs are not so commonly seen in our lab because by default, you should be wearing the gloves and also covered shoes when working in the lab. Biological hazard. It indicates that there's a biohazardous materials handled in the lab. It could also be used to indicate the biosafety level of the lab. Radiation hazard shows that radioactive materials are handled in the lab. The symbol on the top shows that there are flammable hazards in the lab, and hence there shouldn't be any open flame around it. The crossbone and the skull shows poison hazard, meaning that the chemicals are poisonous and can be fatal. The symbol on top depicts a test tube pouring chemicals onto hands and metal surfaces, causing corrosion. Hence, they show the corrosive hazard. You should be wearing proper personal protection equipment when handling them. The symbol below shows electrical hazard. There is possibility of electrocution. Okay, so far I have covered some of the common safety signs and symbols in the lab. Of course, these are not the exhaustive list. In case if you see some of the symbol in the lab which you don't recognize, it's always best to check with your lab instructor. So having learned so much about the safety practices in the laboratory, eventually we want to prepare all of you to be able to work safely in your respective industry. So at this last segment of the first topic, we want to spend some time to look at the importance of following the safety practices in the different industries. The main working hazards when working in the pharmaceutical and biomedical industries include the following. First of all, the handling of biological agents which may contain pathogens. And to be honest, sometimes we really know very little about these pathogens, which makes it even more dangerous. Work-related exposure to biological agents may be associated with several health problems, including infectious diseases, cancer, and allergies. Hence, you should always be wearing the proper personal protection equipment and also handling the biological hazards in the biosafety cabinets. Secondly, needle stick and sharps injuries are also quite common because you might be handling the needles and glass slides. These are actually one of the major risk factors for the bloodborne infections. Thirdly, as a pharmaceutical student, you might be preparing drugs using the various chemicals, and some of the chemicals can be cytotoxic. Again, proper PPE is really very, very important. On the right-hand side, this information is taken from the Australian government website. So according to them, worldwide, around 320,000 workers die each year from communicable diseases caused by work-related exposure to biological hazards. To me, I think this figure is really very, very alarming. So we could not emphasize more about the importance of following the safety practice in the industry. The main concern of working in the chemical industry is definitely the use of hazardous chemicals, which can be toxic, flammable, or explosive. If we don't handle the chemicals properly, serious accidents can happen. For example, fire, explosion, leading to injury and even death of the people, and also the damage and loss to the properties. Locally, we also see such accidents happening. For example, you might still remember the Jurong Island chemical plant fire, which happened in 2020. So upon investigation, they found out that the fire broke out when the hose connected to the nitrogen supply ruptured owing to high pressure. So here we are talking about the high pressure generated by the compressible gas. Later on at the subsequent topics, we will also talk about more in depth on the chemical hazard and how to handle them properly. When working in the food industries, for example, in the F&B environment, in the kitchen, or in the manufacturing plant, these are the main working hazards. Slips, trips, and falls due to the wet floor, scalding and burns by hot liquids or steam during, for example, cooking of the food or thermal processing of the food, handling of the sharp objects and knives. This is more typical in the kitchen environment, and injury due to improper handling of the machinery. So on the right hand side, this is the news from Canada in year 2022. So basically, one of the workers in this company was seriously injured in an accident involving a noodle machine. So the worker was feeding dough into a noodle machine and got caught in the gauge ropes and eventually sustained serious injuries. So in this case, the company was fined very heavily for not following some of the important safety practices. But I think as employees ourselves, we should also be aware of the potential safety hazards at work and know how to protect ourselves from them. When working in the veterinary industries, you will be dealing with animals. So the main working hazards are cuts and infection, bites and scratches from the aggressive animals. And there's also the possibility of a zoonotic disease. For example, one of the quite serious one is the rabies. Okay, so on the right hand side, this is just a report from the British Veterinary Association. So the article says that majority of the farm animal vets report being injured at work. But the farm animal is actually referring to the bigger animals. But I think maybe not so common in Singapore, because in Singapore probably we are mainly dealing with the smaller animals. But the cuts and infection, bites and scratches, zoonotic diseases, these are still quite real hazards at the workplace. Okay, so you still need to know how to protect yourself from them. Okay, we have come to the end of topic 1. To summarize on the topic 1, these are the things we have learned. Firstly, the principles of GLP, the 5S system for good housekeeping in workplace. And we also have covered quite a bit on the laboratory safety, which includes the basic laboratory safety rules and practices. Examples of lab safety equipment, namely the fume hoods and biosafety cabinets. Some of the common laboratory safety signs and symbols. And lastly, we have talked about the importance of following the safety practices in the various industries.